Hello, welcome. Today's video is about the hyperbolic and inverse hyperbolic functions of the complex number. Today I have 3 examples for each, and let's go first to the hyperbolic function before the inverse. So for our first example is to find the value of the sine hyperbolic of the complex number. Remember the property of the sine hyperbolic x plus jy is equal to the sine hyperbolic of x times the cosine hyperbolic of jy plus the cosine hyperbolic of x times the sine hyperbolic of jy. And moving forward, we have the sine hyperbolic of the complex number is equal to the sine hyperbolic of 0.942 times the cosine hyperbolic of j 0.429 plus the cosine hyperbolic of 0.942 times the sine hyperbolic of j 0.429. And then remember that the cosine hyperbolic of jy is equal to the cosine of y, and the sine hyperbolic of jy is equal to the j sine of y. After that, we can now use a calculator to find the value of the sine hyperbolic of the complex number. And for this problem, the value is 0.989 plus j 0.61. For our second problem, we have to determine the value of the cosine hyperbolic of the complex number. And remember another property, that the cosine hyperbolic of x plus jy is equal to the cosine hyperbolic of x times the cosine hyperbolic of jy plus the sine hyperbolic of x times the sine hyperbolic of jy. Then we will use that property to our given, equal to cosine hyperbolic of 0.942 times the cosine hyperbolic of j 0.429 plus the sine hyperbolic of 0.942 times the sine hyperbolic of j 0.429. And then the cosine hyperbolic of jy is equal to the cosine of y, and the sine hyperbolic of jy is equal to the j sine of y. Now we can solve the value for the cosine hyperbolic using a calculator in complex mode and in radian mode. So the value for the cosine hyperbolic of the complex number given is 1.34 plus j 0.45. For our third example, we have the difference of the square of the given from the example 1 and example 2. And since we have calculated the given for both the sine hyperbolic and cosine hyperbolic, it is now easy to determine this value. So we can substitute the values acquired before. So that is just 1.34 plus j 0.45 squared minus the sine hyperbolic, which is 0.989 plus j 0.61 squared. And using our calculator in complex and radian mode, the difference is now 0.987 minus j 5.80 times 10 raised to negative 4, or equal to 0.987 minus j 0.00058. And that is the value. Now let's go to the inverse hyperbolic of a complex number. And our first example is the arc sine hyperbolic of 1 minus j2. First, we will let a equals to arc sine hyperbolic of 1 minus j2. Then get the sine hyperbolic of both sides. We have sine hyperbolic a is equal to 1 minus j2. And sine hyperbolic a is equal to e raised to a minus e raised to negative a all over 2. And equal to 1 minus j2. Then we will cross multiply, that is e raised to a minus e raised to negative a equal to 2 times the 1 minus j2. Then we will multiply both sides by e raised to a. Then that is e raised to a squared minus e raised to 0 equal to minus 1. Then equals 2 times 1 minus j2 times e raised to a. Then we will transpose the variables so that we will form a quadratic equation, that is e raised to a squared minus 2 times 1 minus j2 times e raised to a minus 1 is equal to 0. E raised to a equal to the negative b. And our b here is negative 2 times 1 minus j2. And plus minus the square root of b squared. Minus the 4, a is 1, and the c is negative 1, all over 2 times a, which is 1. And then that is e raised to a, then simplify, that is just 2 times 1 minus j2 plus minus distribute the power, that is negative 2 squared times 1 minus j2 squared minus 4 times 1 times negative 1, that is positive 4. And then e raised to a is equal to 2 times 1 minus j2 plus minus the square root, and we have a common, that is 4, so take the square root, that is 2, and the remaining is plus 1, and the 2 will cancel each other, and e raised to a is equal to 1 minus j2 plus minus 1, or the square root of 1 minus j2 squared plus 1. And we will get the ln of both sides, that is a is equal to 1 minus j2, or ln of 1 minus j2 plus minus the square root of 1 minus j2 squared plus 1. And the arc sine hyperbolic of 1 minus j2 is equal to ln of 1 minus j2 plus minus the square root of 1 minus j2 squared plus 1. The next example is the arc cosine hyperbolic of 1 minus j2. First, we will let A equal to arc cosine hyperbolic of 1 minus j2. Then, take the cosine hyperbolic of both sides, that is cosine hyperbolic of A equal to 1 minus j2. And cosine hyperbolic A is equal to e raised to A plus e raised to negative A all over 2. Then we will cross multiply, that is e raised to A plus e raised to negative A is equal to 2 times 1 minus j2. Then we will multiply by e raised to A on both sides so that it will become a quadratic equation. And e raised to A squared plus 1 equal to 2 times 1 minus j2 times e raised to A. Then we will transpose, that is e raised to A squared minus 2 times 1 minus j2 times e raised to A so that will become a quadratic equation. And e raised to A is now equal to the negative of B plus minus the square root of B squared minus 4 A is 1 and C is also 1 all over 2 times A, which is 1. Then we will simplify, that is positive 2 times 1 minus 2 plus minus the square root. We will distribute the power, that is 2 squared, that is 4, and 1 minus j2 squared and minus 4 all over 2a j2 squared minus 1. Then cancel the 2, it is e raised to A equal to 1 minus j2 plus minus the square root of 1 minus j2 squared minus 1. Then we will get the ln of both sides, that is just A is equal to the ln of 1 minus j2 plus minus the square root of 1 minus j2 squared minus 1. So the arc cosine hyperbolic of h of 1 minus j2 is equal to the ln of 1 minus j2 plus minus the square root of 1 minus j2 squared minus 1. Our last example is the arc tangent of hyperbolic of 1 minus j2. First, we will let A is equal to arc tangent hyperbolic of 1 minus j2 and take the tangent hyperbolic of both sides, that is tan hyperbolic A equal to 1 minus j2. And using a trigonometric property, that is sine hyperbolic A over cosine hyperbolic A, which is also equal to e raised to A minus e raised to negative A all over 2 over 2. Then the 2 will cancel each other and the remaining would be e raised to a minus e raised to negative a all over e raised to a plus e raised to negative a equal to 1 minus j2. Then we will cross multiply, that is e raised to a minus e raised to negative a equal to 1 minus j2 times e raised to a plus 1 minus j2 times e raised to negative a. Then we will multiply both sides by e raised to a. That is e raised to a squared minus e raised to 0 equal to 1 equal 1 minus j2 times e raised to a squared plus, that is 1 minus j2 times e raised to 0, that is 1. Then we will transpose, that is e raised to a squared minus 1 minus j2 times e raised to a squared equal to 1 plus 1 minus j2. Then we will factor out the e raised to a squared, that is 1 minus 1 minus j2. Then it is equal to 1 plus 1 minus j2. Then we can simplify these both terms, that is e raised to a squared times, and that is j2 equal to, that is 2 minus j2. And then we can divide both sides by j2. Then the j2 will cancel and the remaining would be e raised to a squared equal to 2 minus j2 over j2. Then we will take the square root of both sides. Then it will be e raised to a equal to the square root of 2 minus j2 over j2. Then we will get the ln of both sides, that is a equal to the ln of square root 2 minus j2. And we can divide the 2 minus j2 by j2, and that is equal to negative 1 minus j. Negative 1 minus j. So the arc tan hyperbolic of 1 minus j is, or 1 minus j2 is equal to the ln square root of negative 1 minus j. In this module, I learned the hyperbolic functions and the inverse hyperbolic functions of the complex number. And also, I learned the sum and difference property in the hyperbolic and the corresponding equivalent for the sine hyperbolic of jy, the cosine hyperbolic of jy, and the tangent hyperbolic of jy. Now it is easy for me to derive the inverse hyperbolic function and not just memorize the given formula.